welcome to Chapter 5, finally. So Chapter 5 is going to deal with, I believe, rationals, exponents, all those different types of things, radicals, all those different types of things, with Chapter 5. So we're going to start out today looking at integer exponents, and we're going to skip the scientific notation piece of it today. We're just going to use the product rule, define zero and negative exponents, quotient rule, power rules, and simplify expressions are the 5 things that we've got for about our 20-minute lesson today. We'll attempt to keep it underneath 20 minutes, as we always kind of do. So our objective 1 is to use the product rule for exponents and what exactly that product rule for exponents means. So if m and n are natural numbers and a is a real number, then a to the m times a to the n is equivalent to a to the m plus m. So you add exponents. So that is, when multiplying powers with like bases, you keep the same base and you add your exponents. So let's say we have something like 2 to the 4th times 2 to the 6th. Your base is going to remain the same as 2. Don't change the base. And then you're going to take and you're going to add your exponents. So 6 plus 4 is 10. So 2 to the 4th times 2 to the 6th is the same thing as 2 to the 10th power. When you multiply with like bases, you add the exponents. And that's how these are always going to be done today. So if we apply it, m to the 8th times m to the 6th, they have the same base. Since they have the same base, we're going to add the exponents. 8 plus 6 is 14. We're done. We move on to the next one. M to the 5th times p to the 4th. Not the same base. If it's not the same base, there's nothing you can do. You're done. It can't be simplified any further because m and p are not the same base. So the product rule doesn't apply. It has to be the same base. Okay, what about this one when you got numbers out front? Well, treat numbers just like you've always treated numbers, taught numbers, done, whatever. Anyway, you multiply. So you just multiply the numbers together. Negative 5 times negative 9 is 45. Your bases are the same, 4 and 5, add them together to get your answer. You end up with 45 p to the 4 plus 5, which is 45 p to the 9th. Done. Okay. Same thing with this one. Throw more in there. It doesn't really matter. Same thing happens. Multiply the numbers together. Put like exponents together. So 7 times 3 is 21. You've got x squared and x. Keep in mind that if there's nothing there, there's understood to be a 1 there. So there's understood to be a 1 right there. So that's 2 plus 1, which is 3. And your y is 3 plus 4 is 7. So negative 21 x to the 3rd, y to the 7th. It is simplified. That's the product rule. All right, so our next objective then is to define zero and negative exponents. So anything to the 0 power, doesn't matter what the base is, anything to the 0 power, the answer is 1. So I could have 8 billion to the 0 power, and the answer is going to be 1. You can have this complicated thing, x to the 16th times 4x to the 8th minus 3x squared. And if it's all to the 0 power, the answer is 1. Anything to the 0 power is 1. Okay, keep that in mind. So evaluate 29 to the 0, 1. Negative 29 to the 0, 1. Negative 29 to the 0. Now, this one you gotta be a bit careful with because the only thing being risen to the power in this one is the 29. So this is actually that, so negative 1. Be a little careful with that one. 8 to the 0 minus 15 to the 0. 1 minus 1. Because remember, the 15 is the only one being brought to the 0. So the answer is 0. So just be careful. Watch where the parentheses are. Make sure you know what's taken to the 0 power. Inside of the parentheses is where it's at. Okay? Negative exponents. Our negative exponent rule says that if you have a negative exponent, so a to the negative 1, that's the same as 1 over a to the positive of what was ever there. So if I have 6 to the negative second power, This is equivalent to 1 over 6 to the second. Those two things are equivalent to each other. They're exactly the same thing. You could say then, well, I guess that's 1 over 36, which it is, because 6 squared is 36. But anything to the negative power, so n to the negative fourth, is going to be 1 over n to the fourth, and so on and so forth when we're talking about negative exponents. Now, there's a little bit of a caution. A negative exponent does not indicate negative numbers. Negative exponents lead to reciprocals. So negative 3 to the negative second is 1/9. It's not negative, it's just 1/9. Okay? So let's look at a couple of examples. Write exponential with only positive exponents. Well, 6 to the negative 5, 1 over 6 to the 5. 2x to the negative fourth. It says where x can't be 0 because you can't divide by 0, so everything's being taken to the denominator. Since it's inside parentheses, everything's in the denominator. So that's 1 over 2x to the fourth. See, it's a little different now. Look at what happens now. What's being to the negative fourth power? Is the negative 7? Like this one was, the 2 was, but notice how the negative is just right here. So it doesn't affect that negative 7. So that negative 7 is going to stay right where it's at. So it's negative 7 times 1 over p to the fourth, which simplifies to negative 7 over p to the fourth. Just got to be careful again. What's being taken to that negative exponent and what can be moved. Okay? And again, you could evaluate this 1/4, 1/4 minus 1/2, and so on and so forth. Okay? So there's the negative exponent rule. Okay, so what happens if we've got something like 1 over 4 to the negative third? What happens if that negative number is in the denominator? Well, here's the neat thing. If you have 1 over a to the negative n, and they might do this later, I don't remember, that's the same thing as a to the n. So 1 over 4, okay, so keep this in mind, just like a to the negative n is equal to 1 over a to the n, it goes the opposite direction as well. 1 over a to the negative n is equal to a to the n. Okay, so if we think about this one, this is really just 4 to the third. They did it a really complicated way that don't do that. It's just 4 to the third. Just move it up to the numerator and be done with it. And if you think about this b, and I'm not going to do it the way they do it, because if I do it the way they do it, it's just going to get confusing as all heck. Get rid of all that. If you think about it, 3 to the negative third, I can move that to the bottom. 9 to the negative 1, I can move that to the top. 9 to the first is just 9. 3 to the third, 3 times 3 times 3 is 27. And then you could reduce that to 1/3. Okay, so just put them in the other place. If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. Okay. They did a complicated way we get the same thing. 1/3. Okay. And again, I just said this. Okay. Special rule for negative exponents: 1 over a to the negative n is a to the n, and a to the negative n over b to the negative m is b to the m over a. So just flip them. If they're negative in the denominator, move it to the numerator and make it positive. If it's negative in the numerator, make the exponent positive on the bottom. Okay. Quotient rule. So the multiplication rule was that if you had multiplied, you added the exponents. The quotient rule says if you divide, you subtract the exponents. And you're always going to go the bigger one minus the smaller one. Okay, the bigger exponent meaning the higher number. Okay. And then you're just going to leave it where it's at. Okay, so you're going to subtract. So I might do this a little bit differently than they do. I look at this and I say, okay, we're dividing, so we're going to subtract. What's bigger, 8 or 13? 13 is bigger than 8. So this means I'm going to make the top a 1, and this is going to be m to the 13 minus 8. Well, that's going to give me 1 over m to the fifth. There's your solution. And you're done. Don't want to have negative exponents. We only want to deal with positive exponents. And we've got a positive exponent there. Okay, so let's see how they do it, if it's any different. Okay. Same thing. They just did the 8 minus the 13 and got negative 5, but since we can't have positive, same answer. Okay. Same base. Which is a bigger number? Which is further to the right on the number line, negative 6 or negative 8? Negative 6 is bigger. It's further to the right than negative 8. So this is going to be 5 minus 6 minus negative 8, which is 5 squared. And you're done, which is 25. Done, finished, move on. Okay. Do they have the same base? If they have the same base, the rule doesn't apply. Can't do anything with it, you're done. I'm going to sneeze. Sorry. You're going to deal with it. I'm not editing it out this time. I'm only at 11 minutes and 17 seconds. We're good to go. Power rules for exponents. So what happens if we go like a power to a power? So 3 squared squared. Right? When you go to power to a power, when you go power to a power, you are going to go, so like a to the m to the nth power, that's equal a to the mn. So you multiply those two powers together. Also, when you go to a power, make sure that you distribute that power into both places. So ab to the m is the same thing as a to the m, b to the m. You have to distribute that out. Or when you divide, I kind of got it mixed in there a little bit. A divided by b to the m is the same thing as a to the m divided by b to the m. And remember, they're just doing these. B can't be 0 because you can't divide by 0. Okay. So when you raise to a power, you multiply. Anytime you raise to a power, you multiply, and remember to distribute that in there. So in this case, we're going 5r to the 4th power. That's going to be r to the 5 times 4, which is just 20. There's your solution. They're done. Okay. That says 20, r to the 20. Okay. Now in this case, you need to distribute that 2 to everything. Everything. So you have to have negative 1 squared, 3 squared, y to the 5th. All of these things need to be squared. It has to distribute into each of them. A negative times a negative is a positive. 3 squared is 9. Y to the 5th squared is y to the 10th. There's your solution. Make sure you go whatever power that is. Make sure you do that to every one. And understand here, this is 3 squared. 3 squared is 3 times 3. And that's where we get the 9 from. Keep that in mind. Okay. They did it a little differently than I did. Same answer. Excuse me, same answer. Again, make sure you distribute that cubed into each part. So it's going to be 3 cubed over 4 cubed. And whatever 3 cubed is and whatever 4 cubed is. 27 over 64, I think is what it is. Whatever that is. Again, making sure you distributed it in. With negatives, I wouldn't necessarily do it like this. I just bring them in as negative exponents, multiply, and then flip it at the end. This says essentially that if you've got, you can flip it right away and make it positive. I wouldn't do that. Just distribute the negative in there and then flip it when you're done. Okay, so let's look at some examples. So I would rewrite this. My way to do this is to just say, do 2 to the negative 4th over 3 to the negative 4th. And remember, you can't have negative exponents. So you're going to have 2 to the 4th and 3 to the 4th. And then whatever that is, I don't know, 81 over some big number is whatever that is. They're going to do a little bit differently when they do it. Okay, they're going to say, we're just going to flip it first and make the 4 positive, but it's the same thing. You still get 3 to the 4th over 2 to the 4th, so 81 over 16, right? That was a short one. So kind of definitions. Product rule you add, quotient rule you divide. 0, anything to the 0 power is 1. Negative, don't leave it, move it. Power, you multiply. And then there's special rules that we don't use. So all of that leads then to those different rules. It's 15:22. We've got 4 minutes. Okay. Leads to taking these and simplifying these way down. So let's say we've got 4 squared to the negative 5th power. That's just going to be 4 squared to the negative 5th, which is going to be 4 to the negative 10th. We don't like it to be negative, so it's 1 over 4 to the 10th. That's your solution. No negative exponents. You don't need to worry about writing out 4 to the 10th. That is an awful big number, so you don't need to do that. So this one, it's x to the negative 4th times x to the negative 6th. What do you do when you multiply? You add. So negative 4 plus negative 6, so it's negative 4 plus negative 6, x to the negative 10th, which is 1 over x to the 10th. Okay. There must have been more in there, but whatever. We did a little bit different. All right, so now let's look at this one. It's now a little bit more complex. Okay, so we've got something to a power. So I'm going to do inside the power, so that negative 2 needs to be distributed to everything. Get rid of all that that's in the way. So that gives me m. When you go power to power, you multiply. So m to the negative 4th, n to the negative 2nd, all of that over m to the negative 3n. And now we've got m's on both the numerator and the denominator. Which is further to the right? Negative 3 or negative 4? Well, negative 3 is, so that tells me it's going to go here. And it's going to be negative 3 minus negative 4. Where's the n bigger, top or bottom? What's bigger, 1 or negative 2? Well, 1 is. So this is going to be n to the 1 minus negative 2. Since there's nothing on top, we just put a 1 there. Solution, m to the negative 3 minus negative 4, that's just m. 1 plus negative 2 is 3. So there's our solution. Multiple pieces put together, making sure we run them and run the gauntlet. We got the same answers they did. They did a little differently. There's nothing wrong with that. Okay. Next one. A little more complicated still. So I'm going to break it down. I'm going to do the first part first. 2 squared is 4. Y to the 2nd. I have to distribute the 2 there, there, and there. It's power to power, so it's going to be x to the 6th. I'm just going to go ahead and distribute this in here. This is going to be 4 to the negative 1. Y to the negative 1 over x to the negative 1. Okay, so let's look at this. So now we're multiplying. This has an exponent of 1. So 4 to the 1 times 4 to the negative 1 is 4 to the 0, because you add exponents. Y, 2 plus negative 1 is 1. 6 plus negative 1 is 5. Anything to the 0 power is 1. So that's y to the 1st over x to the 5th. And that's your solution. Piece by piece by piece, making sure you distribute when you're doing power to power. Make sure you distribute things where they need to be done. So that's what you're going to look at today with these. You're going to look at the different rules, product rule, quotient rule, zero rule, all those different types of rules. About 10 questions is about what you're going to look at on your assignment today. We're not going to worry about that scientific notation part. So I am at 1957, 58, 20 right now.